example, we have magnesium, which is symbol is big M little g, is going to react with hydrochloric acid, HCl, to yield hydrogen gas plus magnesium chloride. Okay, now this is not a balanced equation because it's actually supposed to be like this. You don't need to know how to do any of this. Don't worry. It's a little 2 on the end of the L there. Now, this is a chemical equation. Okay? It has the chemical symbols of this reaction, of each of these substances. But what you need to understand is that there is an order to writing a chemical equation. What ends up being on the left side of the actual equation, okay, so anything on the left side of this arrow, these are called your reactants. Because they will be mixed together to cause a chemical reaction. Okay? Now, once they're mixed together, that reaction will take place and it will give you products. Okay? Products, just like multiplication, the product is the answer. It's what you're left with after the reaction's taken place. Okay? Products are always on the right side of the arrow. The arrow is called the yield sign. So it means that this plus this on the reactant side is going to give you or yield this plus that, okay? In this case, if we mix 1 atom of magnesium, or actually in this case there's 2, we mix 2 atoms of magnesium with 2 molecules of hydrochloric acid, mix together, do whatever, they might bubble, they might, give off heat, they're going to do one of those 5 things that we talked about when we talked about what a chemical reaction is, and they're going to give rise to new substances. What ends up happening here, notice how on this side of the equation, I have Mg, right? I got Mg there. What other letters do I have? What other substances? I've got some H, and I've got some Cl. The Cl are grouped together because we know that a substance, an element that has a capital letter and a small letter, they're grouped together. Okay, so in the case of sodium, Na, this is 1 unit. Because this letter is small, it gets stuck onto this guy. Whereas if I have, let's say, CHO, how many elements are there? 3 elements are there because they're all capital letters, big letters. Okay? Now, what ends up happening with this, let's look. We've also got Cl, right? On this side, what elements do we have? We have H's as well. There's also magnesium and Cl. Look at that. The same kinds of atoms that you started with, you're going to end up with. The only difference is they break apart if they're stuck to somebody. In the case of hydrochloric acid, H and Cl are stuck together. They're bonded. When they come into contact with magnesium, Magnesium breaks apart that bond and it rearranges it. The magnesium goes to the chlorine and says, come on over here with me, and bonds to the chlorine, and the hydrogen is left by itself. Okay? The same elements are involved, they just get rearranged on the product side. Does that make sense? Now, there's a reason that the numbers, the amounts of the elements don't change. Something called the law of conservation of mass, okay, or matter. That law it means that you cannot make new material out of material that already exists. If you have 5 apples to start with, even if you blend those 5 apples with an electric blender, you're still going to have 5 apples. They just might look like soup, but they're still going to be those same apples. The law of conservation of mass tells us that whatever we start with on our reactant side, we have to end up with the same amount of stuff on our product side. But it can be rearranged. Okay? Does that make sense? So in this case, if we look at this actual reaction again, and we go magnesium plus HCl yields H2 plus magnesium chloride, and there's 2 of those little guys. What we're saying here is that on the reactant side, these are all my reactants. In this case, I have 2 reactants, right? I got 1 substance and I got 2 substances. The reason I know that there are only 2, because the plus sign separates them. I could have 3 substances. I could have 4. I could only have 1. It doesn't matter. Okay? And just because I have a set number of substances on one side does not mean I have to have the same number of substances on the product side. Certain reactions, and I'm just going to give you a reaction here as an example. Hydrogen peroxide, H2O2. Okay, you know peroxide you put on your injuries and it disinfects, makes little bubbles, and it helps kill bacteria, and then you put a bandage on. This is the chemical formula for hydrogen peroxide. Okay? Words: hydrogen peroxide. Oops, that's an R. Peroxide. Okay? This is one substance. In terms of its chemical reaction, it gets broken down into hydrogen gas and oxygen gas. So this is a really good example of having one reactant giving you how many products? 2 separate products. Does that make sense? Okay, so in this case, magnesium and the 2 molecules of hydrochloric acid are going to react when they're all mixed together. And what ends up happening here, during that reaction, I like to look at these guys as a couple. Okay? They're like boyfriend and girlfriend, girlfriend and girlfriend, boyfriend and boyfriend. I don't care. They're a couple. They break up. So it divides them right down the middle. It separates them. Okay? But they don't want to be separated for very long. They're not stable like that. So what ends up happening, the magnesium says, ooh, well, Mr. Chlorine, I'll come and bond with you. And in this case, hydrogen is left by itself. Okay? So yes, we have two reactants and we have two products, okay? But they're not the same types of molecules that we started with. They're slightly different. Does that make sense? Yes? What I need you to know in terms of chemical reactions and chemical equations and word equations, I need you to understand what reactants are. Okay? What are they? Where are they? Where are they on a chemical equation? I need you to understand what products are. I need you to understand where they belong. Okay? These guys are on the left. These guys are on the right of a chemical equation, right? They're on the right of this yield sign. Yes? I need you to understand that. I also need you to know that the product side, so if I have reactants yields products, right? I need you to know that the number of elements is equal to the number of elements. We prove that right here with our magnesiums, writing out the M's, the G's, and the H's. Okay, I believe here, M's, H's, and Cl's is equal to M's, H's, and Cl's. There's no additional, other letters there. The same number of elements and the same kind of elements on both sides. Okay? There's also going to be the same number of atoms. Total number of atoms. Or sorry, that should be an equal sign. So if I go back to that original equation, okay, I've got one atom here on this side. How many hydrogens do I have? Look at that equation. This number here gets multiplied by the H, and it also gets multiplied by the Cl. So I've got two H's, right? How many chlorines do I have? On this side, how many magnesiums do I have? I only have one because if there's no little number here, it's understood that it's a 1. Okay? So I only have one. How many hydrogens do I have? I have 2 of them because there's a small little 2 there. How many chlorines do I have? I also have 2. So do these numbers line up? 1 is equal to 1. 2 hydrogens are equal to 2 hydrogens. 2 chlorines are equal to 2 chlorines. This equation follows the law of conservation of matter.